Good evening, everyone. It's Friday night at the Leitner Observatory. What better time than to observe some killer asteroids? Um, if it doesn't stay cloudy, at least. It's looking kind of cloudy right now. Let me get my camera going here. Hi everyone, I'm Michael Faison. I'm the director of the Leitner Observatory and Planetarium, and I'm a lecturer at Yale. I teach some classes on observational astronomy here. Sometimes in the summer I help high school students do research on supernovae and asteroid orbits and miscellaneous topics like that. And so I was very interested in getting some images for research of this near-Earth asteroid called Apophis. Which was discovered in 2004, and for a brief period of time, it was the asteroid most likely to hit the Earth. And there was a prediction that it would come very close to the Earth in 2029 and perhaps collide with the Earth. There was quite a bit of uncertainty in the path. And soon, though, astronomers found archived images. This is back in December of 2004. Let's see. I went looking for some articles about this. 2004 MN4. This was the provisional designation for this asteroid called Apophis. And for a brief period of time, a few days, it was the riskiest asteroid. Now, the Earth gets hit by asteroids all the time, every day. Tons of asteroids hit the Earth today. They burned up in the atmosphere, probably. We'll have to wait and see if any of them caused any damage. But they burned up in the atmosphere, and every few years, a big one comes down that might leave a meteorite somewhere. Most of those are never discovered or even observed. And every few tens of years, there's a bigger one that people notice and might cause some damage, like the one in 2013, the Chelyabinsk meteor and meteorite. And something the size of Apophis is in the realm of it could cause some real damage based on its speed and its size, the kinetic energy that it would bring to the Earth. So we would like to know its orbit really well. And so anyway, in 2004, astronomers went back and looked at some archived images and recalculated the orbit and discovered that it really was not going to hit the Earth, at least in 2029. It's going to be a close flyby. So it had odds as high as 1 in 37 of hitting the Earth on Friday, April 13th, 2029, which was the highest any large asteroid had been predicted to have in advance. But quickly, archived images showed that no, it's more like 1 in 300, and then it got even less likely and even less likely. And now we know that there's really no significant chance that this asteroid is going to hit the Earth in 2029. Now, there may be other asteroids that will hit the Earth in 2029 or sooner, and we just haven't found them yet. We haven't noticed them yet. You know, I wouldn't say that's probable, but it's possible. But these asteroids that are as big as, say, 100 meters, Apophis is about 300 meters in diameter. The new name for this, the International Astronomy Union name now for 2004 MN, what was it? MN, what's it? 4. 2004 MN4 is this asteroid Apophis. 9994 something 2. Is the number. Good thing it's not, I don't know, 666 something something something. But we know it's not going to hit the Earth in 2029, but it is going to come very, very close. And so it's actually going to come closer than the moon by quite a bit. It'll be visible to the naked eye, moving across the sky. It'll look like a satellite, basically moving across the sky as it flies by. It's not every day that you get the chance to see a small asteroid without a telescope, with the naked eye, or maybe with a pair of binoculars. So people are excited about this flyby, and of course, after the asteroid flies by the Earth in 2029, the Earth's gravity will deflect it slightly, and we won't know its orbit nearly as well after that deflection. Sort of depends on exactly how close it gets to the Earth, how much it's deflected, and so forth. So it's going to come around again in 2036. So that's about a cycle of 7 years or so that it's coming by. It's going to come by again in 2036, and it's almost certainly again not going to hit the Earth, but we're really not sure. And the further you go ahead in time, really not sure how close it's going to get to the Earth on these 7-year flybys. And I just saw an article a couple of months ago. Let's see, this is from November 2020, that there's an effect that the sun has on asteroids that can provide a very small acceleration. The sunlight hitting the asteroid causes a very small acceleration. This is called the Yarkovsky effect, or the Yarkovsky acceleration. And so there's some new calculations that suggest there's a small chance the asteroid could hit the Earth in 2068. The probability has been going up, and now it's around, what, 1 in 150,000. Pretty unlikely, but you know, if this asteroid hit us, it would be really bad. You know, it's not really like extinction level, like kill all the dinosaurs big, but it would cause a lot of damage. Like we don't want it to happen. And if we thought that there was a high probability that an asteroid this big was going to hit the Earth, then we would want to do something to try to deflect it. Let me see how the clouds are doing tonight. So I'm going to look at my camera. Here's the outside camera, and let me look through the telescope and the dome camera. Yeah, it's pretty cloudy. It was supposed to be clear tonight. If I look at my dark sky predictor, it was supposed to be clear tonight, so I was excited to try to get some images. Now, I've been tracking this asteroid for the last 3 weeks or so. I've probably taken 5 or 6 sets of images so far. You know, this asteroid, it's not like a shooting star. It's more like a planet. It's out there in space. It's moving around the sun. The Earth is moving around the sun. It's closest to the Earth today, and in fact, I think it's closest to the Earth in about 30 minutes. I'll look at that in a second. But it's not dramatically closer now than it was yesterday or the day before, or it will be tomorrow. So there's a period of about a month or 2 or 3 when the asteroid is close enough, we call it close, and it would be bright enough to be seen with a small telescope and so forth. Oh, now that I'm looking at my images, I see questions. Will it pass? Yes, it's definitely going to pass. There's no chance. Today we're fine. At least we're safe from this asteroid. I'm scared of this. No, don't worry about it. It is passing by like a distance of 10 million miles. That sounds about right. So tonight it's flying by. I mean, this whole month it's flying by. It's at a point which astronomers call opposition, which means it's opposite the sun in the sky, which is a really good time to look at planets and minor planets. I'll show you the orbit and where it's going to be here in just a minute. But no, it is definitely going to pass. It's not even getting remotely close to the Earth. There are actually some other medium-sized to large asteroids that are going to fly by the Earth closer in this coming month. None of them are likely to hit the Earth by any stretch. But you know, we don't know what's going to happen in the future. And so this is a very active area of astronomy research. Amateurs tracking these asteroids, professional observatories tracking these asteroids to try and understand their orbits better and how small variations in their orbits could bring them closer to the Earth in the future. You know, and it's not a question of if one of these asteroids will hit us, but when. But again, the big ones are very rare. The small ones are very common. So the one that hit Chelyabinsk in 2013, that one broke up in the atmosphere and bits of it were discovered on the ground. I think it was maybe 10 meters or a little more than 10 meters across. So it was really a meteoroid more than an asteroid. But anyway, it doesn't look like it's going to be, it's not clear right now, but I'm going to check again in a few minutes, and if it's clear, we'll go look for it. But yeah, John and Jean-Michel, And yeah, Edward is saying it's going to pass 44 moon distances away. Yeah, that is correct. It's not going to be close tonight, but it is close enough to see it with medium-sized telescopes, and therefore lots of astronomers are taking images of it this whole month, next month, in order to understand its orbit better and track it through the next pass, so we know exactly where it's going to pass close to the Earth, and then we'll be able to understand it better and where it's going to be in the future, and understand if it could be a risk. What are the chances that it could be a risk? Not today, not in 2029, not even in 2036, but hundreds of years from now is the kind of time scale that we're talking about. I also think this is a really interesting project for students to work on, is taking images of these asteroids, plotting their orbits, thinking about the interaction of gravity and momentum and that kind of thing. So a big part of the reason why I am trying to take images of this asteroid is I want some interesting sample data to give to my students to study a famous near-Earth asteroid, Apophis. In addition to I'm going to send these observations into the Minor Planet Center along with hundreds of other astronomers to improve our understanding of the orbit of this near-Earth asteroid. I am checking the YouTube live chat from time to time, so if anyone has questions for me about what I'm talking about or what I'm doing, feel free to type in your question, and as soon as I see it, I'll try to answer it. Anyway, like I said, I'm really just continuing to check the weather because it was supposed to be clear tonight, and it was clear up until about 10 minutes before I started the live stream. I had the telescope open, had the camera turned on, had the telescope pointed to the right part of the sky, and it started getting cloudy. So we'll see if it clears up enough that we can get an image tonight. If I don't get an image tonight, it's not a big deal for my project. I just noticed there was a lot of public interest in the Apophis flyby, so I thought I would live stream what I'm doing. You get to see an astronomer at work here. If it clears up, I'll try to take these images. I could show you some images from, when was the last time I looked at the asteroid? Wednesday night, maybe? I think, yeah, tonight's Friday night. I think I took images on, it was either Tuesday or Wednesday night, but I can go and show you the images that I got from earlier this week. But just to say a couple of more things about Apophis and why it's interesting and what we know about it. So this is actually an image taken, when was this? This was from March 2nd from this is from the Virtual Telescope Project. Yeah, so this is a remote telescope in Italy. There are a couple of remote telescopes, like SLU is doing live observations. I'm not sure. They have telescopes in Spain and in, this is actually a Connecticut organization. If you don't know about SLU, you should definitely check them out. I have a membership here, and they allow you to do remote observing with their telescopes. And they also do really interesting live streams about astronomy events like this one and eclipses and things like that. I'm not sure which observatory they're streaming from. Yeah, so they have telescopes in Spain and in Chile. And they have a really great, the best thing about this website and this organization is they really make it easy for someone as a beginner, a student, for example, or an amateur astronomer, for example, to come in and do what they call missions, to take images of deep sky objects and learn about observational astronomy. So I do support them and recommend them. Let me tell you, if it does clear up, what I'm going to be doing to look at the asteroid, and a little bit about this asteroid. So if I want to know where anything in the solar system is, I go to NASA JPL, right, the Jet Propulsion Laboratory. They put a rover on Mars, not just the recent rover, they put 5 rovers on Mars and robotic spacecraft around Jupiter and Saturn's moons and so forth. So they know what they're doing. And JPL is has a good database that keeps the orbital elements, the orbital parameters of many, many small asteroids, planets, moons, spacecraft, et cetera, et cetera. So I use this interface called Horizons, and I just tell it What object do I want to look at? 99942, that's the number for Apophis, provisionally known as 2004 MN4. I could put the name of any asteroid or comet or planet or anything in here. I'm observing from the Yale Observatory, which is MPC code 9797. That's our code and that's our location. And then I say, okay, well, what's the time span for which I want the astronomer's coordinates? And then I say, okay, show me the coordinates. I already did that earlier. And it tells me all sorts of interesting stuff about the asteroid. You know, I can look and see what is its size. Its radius is 0.17 kilometers. So yeah, that's about 300 meters diameter. Here are all sorts of technical information about the shape of its orbit. And then down here, I scroll all the way down here, and it tells me the astronomer's coordinates at these times. These are like celestial latitude and longitude. And it tells an astronomer, where do you point your telescope to look for where we think the asteroid is going to be at these times. Now, they have a fairly good model already for this asteroid. Sometimes for newly discovered asteroids, they don't have as good of a prediction as to where it will be. And then it's actually really advantageous. It's really helpful when amateur astronomers or astronomers at small observatories track these new asteroids and send in new measurements to the Minor Planet Center so that we can better understand their orbit. So all of these numbers, a lot of numbers here, but the important thing is the date and the time. This is the time in universal time. Let's see, universal time right now is, Eastern Standard Time, which is where I am, is 5 hours behind universal time. So it's already tomorrow. You know, today is March 5th, but in Europe, it's already tomorrow, and universal time is 0247. So if I look at the time associated with 0250 right here, here are the proper coordinates in terms of celestial latitude and longitude, where you'd point your telescope in order to find the asteroid. And apparently it's about 40 degrees, 40.4 degrees to the horizon, above the horizon. That's really helpful if you're looking, you want to make sure that you're going to clear the trees and that you're looking in the right place with your telescope, so that's good to know. And then the other thing that's good to know is the brightness of the asteroid, which is given right here. This is APMAG, apparent magnitude. This is a unit that astronomers use to measure the brightnesses of stars or asteroids or planets, anything. And the smaller the number, the brighter the object. So that's a little bit counterintuitive. So you see it was a little bit brighter earlier today. It's a little bit fainter now, but it's actually a little bit closer to us now, which is interesting. I think it might be a little bit further from the sun, so that's why it's a little bit fainter. So here I see its distance, and this is as a multiple of the distance from the Earth to the sun. So if you were to look at the distance from the Earth to the sun and then the distance from the Earth to the asteroid, it's about 11% of the distance from us to Apophis right now is about 11% of the distance from the Earth to the sun, which works out to be about 10 million miles. Not close. It's not close to us tonight. But I do think it's interesting that the point at which it literally is closest is right about here, and that's in about 30 minutes or so. So let's see, will it clear up? Oh, John's asking, is this an Earth destroyer? No. No. Maybe I should talk a little bit more about the threat of asteroid impacts. 65 million years ago, I'm going to look at my weather camera as I'm answering this just to make sure I don't miss anything. 65 million years ago, the Earth was hit by an asteroid that was 10 kilometers across. So more than a factor of 30 times bigger. And so more than a factor 30 cubed times bigger in volume and mass. So much, much more energy, much, much more devastation, caused a mass extinction, killed off a lot of the large non-avian dinosaurs. The mammals did well, though. The stereotype is that the mammals survived eating all the dinosaur eggs. I don't know about that. But that was a really devastating impact, one of the worst that the Earth ever had. and it was not an Earth destroyer. The Earth was fine. Had a big effect on life on the Earth, but life also got by just fine. And this asteroid Apophis is not an Earth destroyer. It would cause devastation where it hits, but it's not going to cause mass extinction or anything like that. So if anyone has any more questions, I'm happy to answer those. But you really personally have nothing to fear from this asteroid. I hope people aren't getting that from the media about this asteroid. It's not going to cause any harm. It's not going to create earthquakes or 2012 devastation or anything like that. Oh, John's asking what happens if it does hit. Yeah, I mean, it's a good question. You know, it would be right where it hit. It would be like a nuclear bomb going off, right? So you'd have a huge amount of energy in that one place. So you wouldn't want to be under that. But if you think about all of the places on the Earth where there really aren't a lot of people, you know, even in 2021, when we have, 8 billion people or so now on the planet, there's still a lot of empty space. And there was a comet that hit the Earth in 1908 and caused a lot of devastation, but it hit in Siberia. And no one saw it. Not a person saw it. Maybe some Siberian bears and some Siberian foxes saw it. It knocked down trees for hundreds of miles, but no one was even remotely injured by it. And it was about a year later that actually an expedition made it to the site to see what happened, to explore. The sound of it was heard from miles away, which is interesting, but certainly no one was hurt. Didn't really cause any loss of life or significant effect. But you know, if you had a big impact in a populated area, it would really devastate that area, so that would be bad. And again, if we know the orbit really well, we could potentially predict where it might hit. Now, we have the ability to make small deflections to asteroids like this, such that they almost certainly wouldn't hit us, right? So if you're worried about that, you know, do some searches on things like SpaceGuard or planetary defense. NASA has a planetary defense office. You can actually get a job at NASA as planetary defender, which I think is great. And people are looking into what kind of technology, what kind of techniques would you use if we had a prediction that a big asteroid was going to hit the Earth that could cause some devastation. And they're very solid. I can't say tested because, of course, it hasn't been tested. Although, you know, some of the missions to collect samples from asteroids, like the mission that went to Bennu last year, the OSIRIS-REx mission, you know, there was some docking with an asteroid, getting close to an asteroid, getting a sample of an asteroid. All of that experience is relevant to what you might do if you wanted to find an asteroid that was 100 meters across or 300 meters across or a kilometer across, and give it a little nudge sideways so that when it flew by the Earth in a year or whatever, then it would completely miss us. So no, you don't need to freak out. You know, of all the things to worry about, of all the mass, you know, let's say that like global pandemics are something that you should worry about more than significant asteroid impacts. And again, I'm not saying it's never going to happen, because it will. But the really bad asteroid impacts are so rare that we have lots of time to see the asteroid coming and make plans to deflect the asteroid. By the way, you don't want to blow up the asteroid. That's what they do in the movies, right? You don't want to blow up the asteroid. That takes a lot of energy. It just creates just more mini asteroids that are still going to hit the Earth. You want to deflect it a little bit, right? It's like you learn in martial arts. You know, someone's coming at you. You don't take them on head on, you kind of push them to the side and use their momentum against them, right? All right, so I hope I've reassured anyone on the live stream who's worried about killer asteroids. I say killer asteroids a little bit tongue-in-cheek, because it is serious that we want to understand them and track them, but they pose no risk to us now or in the near future. And I guarantee you'll know if we find any that do. So I'm going to try to see if the telescope can take any pictures. So just back to the observing that I'm planning to do tonight. I'm using our 16-inch telescope which is out in the West Dome at the Leitner Observatory. So if you haven't visited the Leitner Observatory, we've been closed for a year. So if you haven't visited the Leitner Observatory, we have these two domes up here. There's the West Dome over here, which has our 16-inch reflecting telescope. There's our observing deck right here. Often for our public nights on Tuesday nights, I do demonstrations using this 12-inch telescope. And then over on the far left of the observing deck, there's the East Dome, which has our 8-inch refractor. It's a historic telescope from 1876 that we use a lot for visual observing on public nights and for astronomy class labs and things like that. So I am, you can see the shutter on the dome is open over there. So this is a computer-controlled telescope. And so it's great because when we do remote classes and remote labs, my students can control the telescope remotely and rotate the dome and point the telescope and take pictures and so forth. And so even though I am here at the Leitner Observatory, I'm inside the staff office inside the building where it's nice and warm, and I've got plenty of light, and I've got a computer, and I've got a cup of coffee right here. I can control the telescope from right here. So if you were to log into our control computer, you could control the telescope. So I won't give you the I won't give you the link and the password. So you know, maybe it's clearing up a little bit. So this is a live camera feed from the telescope itself. And there's a camera pointing along the side of the telescope that helps me see when the telescope is in line with the opening in the dome to allow us to see what's there. So let me try to take a picture with a telescope, and we'll just see if we see anything, and then we can try to move to the telescope. John's asking you, do we know where the asteroid is located now? Yes, we know exactly where it is. I've got the coordinates. If it's clear enough, we'll take a picture of it. We'll see it move. I'll save the images, and later on I'll analyze them and combine them with my other images and project the trajectory and see how well it matches JPL's prediction, see if the data are good enough to submit to the Minor Planet Center, and so forth. So I have software here which allows me to control the telescope and control the camera. So what you're seeing here is a representation of the sky, which is a simulation. This is not an image of the sky. And this red bullseye shows me the object I'm interested in, and then there's a yellow bullseye which shows me where the computer thinks the telescope is pointed right now. So if I switch over to the camera here and I ask it to take a picture, it will take a picture with the camera that's attached to the back of the telescope. Okay, so it's not very clear, but it's a little bit more clear than it was a little earlier tonight. So this is the star Regulus. This is the bright star in Leo the Lion. So there it is right there. So I was pointing at this star a little bit earlier just to check the pointing accuracy of the telescope and the focus of the telescope and so forth. So let's move to where the asteroid is predicted to be and see if I can see any stars there. This camera that I'm using is a very specialized camera for astronomy research. It's a CCD camera. In principle, it's similar to a consumer grade camera, like if you have a point and shoot camera or an DSLR or the camera sensor that's inside your cell phone. In principle, it's the same technology. But this camera has a big sensor. It's about 1 inch across. It has really big pixels. So it has actually very low megapixels. It used to be that cameras were sold by virtue of their megapixels. This one has 1 megapixel. But the important thing is that it's very sensitive to faint light. So you can look at faint stars and faint galaxies and collect as much light as you can coming from the telescope. So I need to move the telescope to the coordinates of the asteroid. So let's go look again what the coordinates of the asteroid are. So I'm going to go back to the JPL Horizons page, and I think I should look at the coordinates for, it's very close to 3 o'clock Universal Time, so 10 o'clock Eastern Standard Time, 3 o'clock Universal Time. So the coordinates that I want are going to be on this row here, March 6th, 3 o'clock. So I want to go to this celestial longitude and then this celestial latitude. So I'm just going to cut and paste so that I don't make any mistakes when I put this into the control computer. So let me go back to the control computer, and I'm going to tell the telescope to move to this celestial longitude, okay? And I'm going to tell it to move to this celestial latitude right there, okay? All right, this is all kind of technical, but this is what I do when I'm observing with the telescope with students or for my own projects. So I'll tell the telescope to move, and you see that little yellow bullseye is moving down. And if I look at the camera that's on the telescope, it's moving. The telescope is actually upside down now relative to the dome, so it looks like it's moving up, but it's actually moving down. I still see a lot of clouds through that slit there in the dome, so feeling pessimistic about getting an image tonight. Okay, now it looks like the telescope is pointing at the side of the dome right there, so I can rotate the dome here. Let's see. So if you were here at the observatory, you would see the dome rotating. Okay, and these should be the coordinates. This should be where that asteroid is. Okay, it's right down there. It's in the constellation of Hydra tonight, a little bit south of the ecliptic, right there. So let's try to take a picture and see if there's anything there. Now I still may need to work on the focus of the telescope, so I'm going to take a longer exposure here, like about a 5-second exposure. So you will see, all right, the computer just told the camera to take a picture. All right, here is the view from the camera. Let me just the contrast a little bit. It's pretty terrible. Now I see some bright stars, so let me just try to confirm that this is what we are looking at. So this is an actual image of the sky taken through the telescope, and I think the stars are a little bit out of focus and they're quite dim because there's a lot of clouds out there. But what I'm going to do is look at this star chart here, and I'm going to zoom in on the star chart and try and compare what I see in this image to, let's change my orientation here, to what I see on the map. I think of this image that I'm using to control the telescope as a map for where the stars should be. And then I take a picture with the camera on the telescope, and I try and match them up. Okay, so I still need to see that image. Okay, so, oh yeah, okay. Okay, all right, I think I'm seeing the asteroid. So let me explain what I'm seeing here. There's that bright star right there is the same as that bright star. And those two bright stars right there are the same as those two bright stars. And then there are a few other faint stars kind of in the field of view there, but they're really tough to see. And then there's all this background light. You see this kind of big donut. I'm not sure how well that's coming across on the live stream. That is light pollution. Basically, it's light from the city bouncing off of the clouds and coming into the telescope and creating that kind of ring of light. I think that's the asteroid right there, because that's where it should be. That's where it should be, and there's no star there, right? So that bright star is that bright star. That's about the right brightness for what the asteroid should be. Now, you may be underwhelmed. Though that little speck of light right there is, I think, and there's a way to confirm this, which we'll do in just a second, I think that that little speck right there represents light from the sun that has traveled about 100 million miles through space, hit the surface of this 300-meter asteroid, come back to the Earth, traveling about 10 million miles, passed through the atmosphere, passed through a bunch of clouds, entered into the aperture of my 16-inch telescope, focused by the mirror in the telescope, triggered some electrons in my camera, and then I've just displayed it on my computer screen. And now I'm sending it out on the live stream. Now, how can I be sure that that's the asteroid? Well, if that's the asteroid, then if we were to take another picture, we should see it move because it's orbiting around the sun. So I think the direction it should be moving is kind of up to the left. So I'm not going to bother to save that image. I'm going to take one more image, and I'm going to put my cursor on where it is now. So let's see if it moves. Maybe. This image is cloudier than the last one. So maybe it moved, but I'm not sure. Let's see here. Yeah. I'm not sure that I see it anymore. Let me go back and look at the cloud camera here. Yeah, it's looking pretty cloudy. I'll look at the deck camera. Now again, for the purposes of my project, it's okay if I don't get images tonight because I got images earlier in the week and I can probably get images tomorrow night or Sunday night. And as long as I take an image like every other day for a few weeks, I can get enough observations to track the asteroid and project its orbit. You can't actually, for just from one image, you can't actually project the orbit. You need to see how the asteroid is moving over many days in order to do, Newton's laws of physics, laws of gravity and laws of motion, and figure out where it's going to be in the future. So I think I'm going to have enough observations. Let me go back and try and take another image. I always want to make sure that I'm looking correctly through the dome correctly. Okay, let's try again. I'm going to try a longer exposure. So that's a 20-second exposure, so it's going to take a little while for it to expose, and then we'll download it and see if there's anything more identifiable. Hey, okay. So this is still not great, but it's a little better. Looks like there's a little bit of tracking error with the telescope. Do you see how the images are a little bit elongated left to right? I think that there might be a little bit of backlash in the telescope tracking, but boy, it's not clear. It's just not clear. But I think that's it because, again, if I try to match up where the stars are in this image, this purple box that I see on my chart is a representation of what the field of view of this camera should be. And so I think those two stars are matching up with those two stars, and that star is matching up with that star. Yeah, I'm just going to let it keep taking images continuously here, and I'm going to kind of use that to monitor the cloudiness. And I'll probably keep checking the sky until about 10:30 or 11 to see if it looks like it's going to clear up. And if not, I'm just going to go home. Oh, okay, that looks a little bit better in terms of exposure, but now that tracking problem is creeping in again. Look and see what this next image looks like. Cloudy. Yeah, so clouds are getting worse. One last thing I'll show you before I decide to pack it in or not. Let's look at this image too. No, cloudy. Yeah, these images look terrible. So shouldn't even be sharing them with the public because they look terrible. There are two things I'll show you before deciding to call it quits for tonight. One thing is I can show you what the predicted orbit looks like based on JPL's best model. So this is a nice feature that JPL has in their solar system browser. So this is the JPL small body database browser. Small body here means like a small planet, minor planet. And here you can see the shape of the orbit for this particular asteroid, for 99942 Apophis. And you can see the orbits of the planets, and it's this nice 3D viewer, which lets you see where Mercury's orbit is, and Venus's orbit, and Earth's orbit. If I kind of grab this and look down from above, you can see that the orbit of this asteroid is not very circular, right? It gets close to the Earth and crosses our orbit and then gets close to Venus. So there is some chance that it could actually collide with a Venus. It'd have to get a little bit closer. And then it comes back out and just a little bit past the Earth. So it's interesting. These types of asteroids, most of the asteroids, of course, are out of the main belt between Mars and Jupiter. So these asteroids that get gravitationally perturbed or migrate from the asteroid belt into the inner solar system and end up in these Earth crossing or Venus crossing or Mars crossing orbits, it's kind of interesting. So you see that, actually, let me center on the Earth. It's really not close to us at all. You can see where it is there. It's below the plane of the solar system, and it is swinging by the Earth right now, but there's a big gap right there. Again, about 11% of the distance from the Earth to the Sun is the distance between the Earth and the asteroid. Now, I'm almost hesitant to show this. I don't want to scare anyone, but we can look and see where it's going to be in 2029. Again, when we know it's not going to hit us. Let's jump ahead by a year. And so there is Earth, and there's Apophis over there. So that's 2022, 2023, 2024, 2025, 2026, 2027, 2028. And then 2029. Okay, so there is March of 2029, and you can see there where it is coming up. Now, yeah, so you can kind of see it's at sort of a similar distance in March of 2029 as it is to us right now, but we're at a different place in Apophis's orbit relative to where it is when it gets close to the Earth. So where it gets close to the Earth is that point right over there. So now if we step forward by a few days, 1, 2, 3, 4, 5, 6, 7, 8, 9, getting closer, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It's getting closer. And the date is down there off the bottom of the screen. Oh, there we go. March 31st. Okay. And there you see the orbit of the moon. And there is April 12th, 2029, and there's April 13th, 2029. So you can see sort of in this basic model how close it's going to get. Now, this is not a super sophisticated modeling program. It's really taking the very basic orbital parameters and projecting where the asteroid will be in the future. When you use a more sophisticated model, taking into account the Earth's gravity and Jupiter's gravity and that sunlight effect, that Yarkovsky effect and so forth, it does actually get closer. But you can see here's how close it gets in 2029 in this particular model. So that's pretty neat. It's pretty exciting. It's going to be fun to watch it fly by. But again, it's not going to hit us. Don't worry about that. The other thing I'll show you is some of my images from earlier this week when I know it was clear. And I haven't looked at these images. I've been busy teaching, so I haven't had a chance to look at them. So let's go see what we've got. Let's see. Let's look at the latest image from the telescope one last time. Hey, it looks like it might be clearing up. That's good. Let's see what this image looks like. Okay, a little bit more clear, although it's I'm getting this weird tracking error, which I think there may be, again, it's some backlash in the telescope gear. So I may have to go outside and tighten that. Okay, there's a better image. This actually looks like a good image, so I'm going to pause that. And let's see. This is a good image. So let's make sure we can identify what's going on here in this image. So, okay, I definitely see the asteroid. Okay, let me see if I can convince you if you happen to be watching live now. So I'm going to try and get, this is the map of where we're looking in the sky. This is the actual image from the telescope on the right. I think I can improve the video quality a little bit so that's a little bit easier to see. I always forget how this remote control software I'm using has a mode to optimize quality so that it looks a little bit clearer. There we go. Okay. So that star and that star are those two stars. And those two stars there are those two stars. And that star there and that star there is that star there and that star there. And so that star right there is that star right there. So that has to be the asteroid. Yeah. Now I'd still like to see it move. So I'm going to save this image. Okay. And I will save it. We save all of our data by date. So I'm going to call this Apophis 1. Okay. And I'm going to try to take another image. The focus is okay. I'm looking at the stars in this image. And they're a little bit elongated left-right, but I think the focus is okay. So let's take another image. Oh, it's cloudy. Oh, I'm so unlucky. That's what clouds look like. And let's go, let me look at the camera. That's what clouds look like. All right. All right, here comes another one. Also cloudy, although I can see that bright star there. This is the thing, is the clouds aren't always completely opaque. You know, sometimes you get a little bit of light coming through. Clouds are moving pretty fast, though. I can see them moving through the camera on the telescope. This is a camera that's mounted on the outside of the telescope that just lets me see what's visible through the slit of the dome. All right, well, I got that one image. I can open that one again. And I am 99.9% sure that's the asteroid right there. I'd really love to get a second image to really convince myself that it's moving. So I'll wait and see a little bit. Did it pass? It's actually getting further away. Let's check that. Let's check the prediction again. It's going to be getting further away starting at 0320. So that would be now, right now. So according to the predictions, it's going to be getting further away from us. This is the distance to the asteroid right here, and this is the speed of the asteroid. So when it's negative, it's moving towards us, and when it's positive, it's moving away from us. So just this in the last minute or two, it's gone from getting closer to us to getting further away from us. Okay, well, I think I'm going to, let's see. Oh, okay, here's a better image. Let me save this one. Okay, and we'll see if we get any. It's not a good image by any stretch, but at least you can see some of the fainter stars. Yeah, it looks like there's a little bit of a hole right there, and I should maybe rotate the dome a little bit. This is what being an astronomer is like these days, doing remote observing and looking and waiting for clouds to pass. This is fairly typical. Okay. Hey, that's also not a terrible image. So I'm going to save that one. Normally, I'm not saving these images individually. I'm, taking a sequence of images automatically. Yeah, and there's that tracking problem. I have to figure out what's causing that. I'm going to go look at those images that I just took. So while these images are being taken, and I think actually what I'll do is just tell it to automatically take and save images. And later on, I'll look to see if any of them are any good. That's not looking too bad, actually. So I'm going to go over here and tell it to take a sequence of 15 images automatically. And later on, I'll look to see if any of them are measurable. I think maybe some of them might be okay. And I'm actually going to save this image. Okay, so I'm going to tell the camera to take those pictures, while in the meantime, I'm going to go look at those images that I just took. Okay, so here's all of our data. So I'm going to look at maybe these first 3 images. Okay. And I'm going to align them so we can look, see if anything's moving. Okay. It's not moving as much as I thought it would. It's moving a little bit, but I'm not 100% convinced. So I'm going to check the coordinates. Boy, that'd be a pain if I was looking at the wrong coordinates. So let's look at that. All right, there's the last image. Okay, so we're going to be interested in the coordinates for, so that's where we're pointed right now. So we're going to be interested in the coordinates for, what time is it now? 03:25. So that's going to be right around here. Nice, there's my celestial longitude. Okay, yeah, that looks right. Looks good. And here's my celestial latitude. Okay, move the telescope up there. Oh, I know what's happening. It's going to turn over to the other side of the telescope mount, so that'll take a minute. So let's see what the weather's doing. Yeah, I think it's probably clouded out. I got those 3 or 4 images, which might be measurable. I'm 99% sure that bright object is the asteroid based on where it is on the star chart. So I'm going to measure that a little bit later on and see if it matches with the other images that I've been taking earlier this week. And I'll be coming up to the observatory when it's clear for the next few weeks and taking pictures of this asteroid. And I'm actually studying another asteroid as well, a brighter one, which is in Leo right now. It's this asteroid called Vesta. And this is an asteroid which is very bright. You can see it with binoculars. You can actually see it sometimes even with the naked eye if the sky's really, really dark. So I've been taking pictures of it with my digital camera just to see, can you actually track an asteroid with just a digital camera and no telescope? So kind of excited to try that project. Okay, I think I'm going to sign off from the stream. If anyone has any last questions for me, by all means type them in the chat. Also, I'm happy to take email questions. If anyone has any questions about astronomy or the Leitner Observatory, asteroids, anything in the news, send me an email. My name is Michael Faison, Faison. My email is michael.faison@yale.edu, so feel free to send me an email. And the Leitner Observatory has a website at leitnerobservatory.org. Sorry, well, we do have a website there, but the main one is leitnerobservatory.yale.edu. That's our main website that we keep up to date. So we're doing live streams on Tuesday nights, and then we sometimes do special events if there's public interest. We'll do another live stream like this in the future. I really hope it's not too far in the future until we can meet in person at the observatory and look through telescopes with our eyeballs and look at constellations and see planetarium shows and so forth. So we'll see how long that's going to take. Oh, here's another question. When will Apophis pass the Earth? It's passed. It's gone. It's on its way away from us. It's heading away, although very slowly. Next pass will be on April 13th, 2029. And that's the one that's worth putting on your calendar, because that's the one where it's going to get bright enough to see with the naked eye. It's going to come closer than the moon. It's not going to hit us. We know it's not going to hit us, but it'll be really interesting to track its progress as it goes by. And I'm going to go check the sky with my actual eyeballs and see if it's getting more cloudy or less cloudy, and probably going to head home tonight and go to sleep. Yes, thank the Lord. And we're going to be fine, I promise. All right, I wish everyone clear skies. Have a great weekend. Tune in on Tuesday for our usual public night live stream, and see you next time. All right, bye everyone.